To understand resources, and more importantly, how resources are used, you really have to go back to a really basic concept, which you guys probably got when you were in grade school or high school. That's the idea of carrying capacity. This is such a simple concept, but it's absolutely devastating because at its basic level, it is the parameter by which survival occurs at a species level. So carrying capacity, very simply, is the number of of organisms in that particular species that can survive in a particular space or region or whatever, whatever your bounded area is, over extended periods of time. So carrying capacity isn't how many, for example, people you can have at one time. Carrying capacity is how many people you can have, say, in Palolo Valley over, say, a 100-year, 500-year period. So carrying capacity is always longitudinal, so it's through time. And this makes sense because you want to look at, in times when you've got good environmental situations, so there's more food available. Then you might have periods where there's bad environmental situations, there's less food available. The number of members of that species that are going to survive is going to go up and down. What you want is the average of all that. That's the carrying capacity. Carrying capacity on islands is pretty visible because you're talking about small bounded areas. I mean, here, this island is only about 34 miles by 27 miles. So it's less than LA County, I'm pretty sure. So carrying capacity on an island is pretty visible because you're bounded by ocean. And so it tends to be much more of you can see it. You can see overcrowding, you can see various conditions literally because it's a very small physical space you're talking about. So example, the carrying capacity of, for example, mongoose on this campus. There's a fair number of mongoose on the campus, and it would appear that they're here and they're particularly happy, and they're just running all over the place doing whatever mongoose do. But the reality is, if you're ever here during the summer, you realize that you see a lot more mongoose running around. The reason, very simply, is there aren't a lot of students here on campus in the summer. People aren't throwing away trash, and a lot of what mongoose eat are basically in the trash bins. So as that food resource disappears, what happens is then mongoose are desperately looking for a meal. And in that situation, what you suddenly realize is the carrying capacity was artificial. The carrying capacity was defined by human occupants and discarding food in the various trash containers here. It wasn't based on the natural, landscape here, if such a thing exists, that the mongoose were consuming. They weren't. The mongoose are here because people are here. If you remove the people permanently, if Chaminade became abandoned, then the mongoose population would rapidly collapse because it's an artificial population. I used to see this when I go running down to Diamond Head at the lighthouse. There's a guy that feeds the cats there every afternoon around 5 or something like that at the lighthouse. And there's a ton of cats at Diamond Head. And one of the reasons there's a ton of cats there is because they get fed. So you can have a larger population of cats. If they had to predate, birds or mice or rats or whatever on that landscape of Diamond Head and survive purely on what they could catch, you'd probably lose about 70 or 80% of those cats. So that's the carrying capacity is artificial. The carrying capacity for people on this island is also incredibly artificial. The current estimates for the actual Hawaiian population that was based on sustainable agriculture and basically subsistence level agriculture here on this island was probably around somewhere between 60 and 80,000 people. And that's probably a little bit optimistic. So, if you look at that in the current situation, we've got 1.1 million, I think, right now this year, people on the island of Oahu. Roughly about 920,000 of that are there just like the mongoose and the garbage cans. They're there because you've got food being imported every day through container ships, all sorts of stuff coming in, very little food being produced here in the Hawaiian Islands, and almost all that considered, largely gourmet, ironically. And then in part, of course, shipped out, like the coffee, which isn't even consumed here pretty much. So, when you're looking at resources, you first have to look at carrying capacity. And one of the problems with carrying capacity, in fact, in the way we look at resources, is we tend to look at them in very small spatial components. So we tend to look at carrying capacity resources within the context of, for example, an island, which at least has the advantage it's visually and actually in some ways technically pretty accurate. But if, for example, you're looking at the carrying capacity of, say, the Central Valley in California, that's a lot more problematic because that's not a separate area. It's part of a larger landmass, North America. It's tied by road and rail, and water gets piped in, and fertilizer and resources move in and out. So it's very hard to actually define that. But it's actually, if you're the government of California, you see it that way. You see it as a defined area. So when you're looking at resources, you have to remember that on one hand, there's a tendency to look at them within a regional context. in terms of this region has this and that region has that, or this region needs this. But the reality is it's a much more complicated dynamic because almost invariably there's more than one region involved, or it's a much larger concept. And so what you get in geography especially is on one hand, the idea of regional use of things. Like, for example, in the American West right now, is an enormous problem with drought. There has been for years, and it's finally come to the point where they're going to have to do something about it. There's just too many people, there's too much use of water, and there is not enough water. So that's a regional thing. It's west of the Rockies. Having said that, when you look at where that water is coming from and where it goes and who's impacted on it, you end up with a much larger geographic component, which is basically all of North America. In fact, you could argue it's even larger than that because your climate systems are not unique. A climate doesn't start and happen in North America. Climate occurs from other places. The rain comes in from somewhere else. Dry winds come in from somewhere else. And this is what we call the Gaia concept. This has been sort of messed with, but in its original form, the Gaia concept was one of the Greek goddesses. But it basically said that you have to look at the whole planet as an organism, or sort of like a symbolic organism. So you could look at, for example, the movement of air and moisture and stuff in the atmosphere and such as being a form of the circulation system. That would include water on ground. You could look at the structure of the landforms as being basically like the skeletal structure of a body. So the idea that you had to look at the key here is the idea that the whole planet has to be looked at as one system. You can't parse out one region versus another region and somehow pretend they're different. And you can see this classic discussions, for example, about water shortages in Texas versus Mexico. You got the Rio Grande River right between the two. They both need the water. But if you're in Texas, you see it as their water. And if you're in Mexico, you see it as your water. The reality is that that's an artificial regionality. It doesn't have anything to do with where the water comes from or even where the water is in the river. It's per virtue of perception and political attitudes and a whole mess of other stuff. And so region uniqueness tends to be a huge problem when you're looking at things like resources, because it tends to almost make all the decision making from within the region. Of course, you can have then, the region of, say, Nevada versus California versus Utah, who all have to share the same river, but they're not going to see themselves as part of a larger whole in many cases because my demands are more important than your demands. So regionality is a real nightmare when you're a geographer working for a government or non-governmental agency, and you're trying to figure out how they're going to sort out a resource in more than one region or more than one perceptual region. So this goes back to this idea of perception again. Okay, here we see an example of this whole issue of resources. This is Southern California, it's near Modesto. This is an area that actually is almost notorious in the fact that the green here that you see are some of the most productive land in the world. The farmers in this part of California can grow more food more quickly than just about any place. Now, having said that, the original landform for this whole area, this used to be part of a lake millions and millions of years ago. So this whole area is very, very dry. You can see here is what it looks like normally. So we just zoom in. This is, it's desert. This whole area was desert. All the area down through LA was all desert. So what happened is in the 20th century, almost entirely, what happened is they started importing water from the Colorado River, and that water actually was the means by which, oh, check that out. Okay, actually, there's the canal right there. I can't remember what the aqueduct is called. So this is actually water from the Colorado River, which I believe is 400 or 500 miles away. So they bring that water in. They were able to do it not really legally, basically, steal the water from other states, bring the water in, and then irrigate all these areas. Now, there's several side effects of that. One is that in the process of using water as a resource, that allowed you to acquire other resources. In this case, classic, industrialized agribusiness type farming, sort of the last of those production systems we've got in terms of food. Now, what you notice here is if you look at this carefully, you realize that when we zoom in, a lot of this area is now, there's nothing there. It's going back to being desert. But if you look at this desert versus that section outside, which has been desert, if you notice there's not a lot of even sage or other type of plants here. This is basically, look at it, it's all covered in a thin layer of salt. In fact, you can see it's starting to have an impact here. So what you've got here is that in this particular area, you had the water come in, you irrigated this whole area. This was originally in farms, just like this spot over here. You can see what's left of the farms here in terms of the irrigation systems. But what's happened is because of a shortage of water, but even more importantly, the fact that you constantly irrigate it. So, every day or month, there'd be sprinklers, sprinkling water out here to make the plants grow. You're putting in tons and tons of fertilizers to make the plants grow, just like these guys. And the problem you get into is because this is an area that's extremely dry, is that water evaporates. And the fertilizers don't go anywhere because this is a low spot. So the water doesn't wash off somewhere. This is as low as it gets. And so the end result of all that is that over time, the salts build up in the soil, the toxins built from the salts, the nitrates build up in the soil. And basically, this whole area becomes sterile. You not only can't grow the trees here anymore, but even the sage or the original plants that grew when it was a desert prior to the water now can't grow here because you basically killed everything. So in that case, what's happened is the use of one resource, water, the use of other resources like fertilizers, nitrates, and such, allowed you to make an enormous amount of money off of this landscape. And farmers did extremely well. They were some of the wealthiest farmers in the world, probably, in terms of what they could get, per one of these blocks of property. But now what's happened is that property is useless. You can't use it for anything. And if you notice, the soil is just constantly covered in this. And this is the result of, over irrigation, over fertilizing, and the water doesn't have anywhere to go. And the end result, you actually sterilize your environment. This was some of the most productive land in the world, and it's now, if you look at it, a good half of it is gone. It's not even productive in the sense of this area where at least you've got sage and stuff growing. You've got nothing there. You can look at the difference right here versus a natural landscape here, and that's that has huge consequences. Not only is this one of the main areas that produces food for the United States and also ships it overseas, but you've still got then your water demands, you've still got fertilizer demands, all sorts of complex relationships in terms of resources. Because you have to remember, fertile land in the sense of agricultural land is also a resource. So when you're talking about resources, it's a really complicated systemic thing. And also notice how this gets back to that whole issue of looking at things regionally. You can bring the water in from somewhere else, but if you're Southern California, you don't care where the water comes in. You want water because you've got to irrigate your fields, and whoever the state politicians are, they're supposed to get you that water. You're not interested in whether they need water in Nevada or Arizona or some other place. That's their problem. And yet, of course, ironically, there's only a limited amount of the resource. And that's true of all resources. All resources have limits. They might be different limits, and there's differential demands on them. But nonetheless, resources by definition are always going to be finite in some way, shape, or form. So we finish up, then there's basically usually considered to be two types of resources, but the first is really a lot trickier than it seems. These are what we call renewable and non-renewable resources. Non-renewable resources are pretty straightforward. That's going to be the coal video you're going to watch. In fact, the water video also, but especially that coal one I just posted for you guys to watch. Coal is a non-renewable resource. Coal actually does renew itself if you're a geologist. In the space of 50 or 100 million years, plants will be trapped in the ground and compressed into coal, which is basically just squashed up plants under enormous heat and pressure. So, coal is technically renewable over the time of the dinosaurs, but coal's not renewable if you're just sitting around there and you bury a tree in a pile of dirt, you can end up with coal. So these are non-renewable resources, which means once you've used them, the buggers are gone. Now, oil is probably the most striking of these because oil is so pervasive in the life that we live in 2021. I don't think about it. You not only have oil in the sense of, gasoline for cars and oil, as lubricants, but of course, plastics are made from hydrocarbons. So plastics come from coal. So in a huge amount of different ways, from oil. So in a huge amount of ways, oil is so pervasive that every bit of stuff that's converted is that much less, because like coal, oil is non-renewable. So the more that you throw away plastics, or the more plastics you need, the more that you have taken that resource out of the ground, and it's not going to be replaceable in the period of human existence guaranteed. So non-renewable resources are pretty straightforward. Once they're used, they're gone. And that gets us back to this region thing. Who should have them? Who should be able to use them, etc. The United States uses an enormous amount of the world's non-renewable resources in a fairly small part of the world's population. We're way out of whack with everywhere else. And that's a constant source of complaints if you live everywhere else on the planet, is the fact that Americans are basically pigs when it comes to using non-renewable resources, and they don't want to share. So, that's, when you talk about this, that impacts politics. If you're a tourist going somewhere, people will see you as basically a giant, vacuum cleaner disposing stuff that maybe just coming from their country or their place, and they're not getting it, you're using it. So, these don't just apply to resources, they spill across the whole spectrum of relationships. Renewable resources are a lot trickier because renewable resources are a lot more ambiguous than they seem. Renewable resources, a good example would be here if you have the green, if you have the two bins, you've got whatever the one bin is, the blue bin is for plastics and glass and paper. And those are considered renewable resources. In fact, that's what that bin's called, that's for renewable. But the problem is renewable resources really aren't. If you look at what we call carbon footprint, because carbon footprint is actually looking at how much energy is used in the entire, if you want, life cycle of a product. So if you're looking at, for example, a piece of cardboard, originally it starts as a part of a tree, say a paper pine in Georgia. So the tree's cut down, that tree is then stripped into little pieces, crushed and turned into paper, which is then taken, and all that's done in one factory, it's then taken another factory, it's turned into cardboard. Then that cardboard is then taken another place where it's cut into a shape of a box or whatever. So you get a box from Amazon. So that cardboard's already gone through a bunch of processes, and all those processes required energy. There was the energy of the trucks to move the trees around. There was the energy for the factory to run and turn it into cardboard. There was the problem of shipping the cardboard from point A to point B. There's the cost of shipping the cardboard in a box from the Amazon, distribution center to your house. And then of course there's what you do with it after that. So you try to be conscientious. You put the cardboard in the blue bin so that it can be recycled. Well, to be recycled, that cardboard then has to be placed in a huge bundle, put on a ship and shipped off to Vietnam, which means it's going to take an enormous amount of fuel energy, i.e. oil again, to take that cardboard to someplace like Vietnam and turn it back into, reusable, recyclable cardboard. And that too requires a large amount of energy. So then that cardboard has to, got that cardboard now is rebuilt, you might say. Now that cardboard has to be shipped, say, back to the United States to be turned into a box to then used again. So if you actually look at that new renewable resources, a lot of them really aren't. A lot of them are renewable in a feel-good way. But a lot of them really aren't renewable in the sense that it's energy and cost and resource effective to renew them. So renewable resources you have to look at very, very carefully. And once you actually start to analyze, the actual carbon footprint of recycling, for example, a resource, then all of a sudden a lot of the stuff that we do, that rhetorically seems like a real good thing that you guys were brought up in grade school, you got to recycle, really is a lot more problematic than it appears. And this is something that geographers have been trying to point out to people for ages, is the fact that renewable resources in most cases really aren't very renewable. In fact, it might require more energy to reuse and recycle that cardboard, or for example, plastics, or even more so glass, than it would to just, cut down a new tree in Georgia and make another piece of cardboard. It might actually be more energy efficient and lower carbon footprint than reusing the cardboard you've got, which then in this case, you just take it as we do right now. We can't afford to ship it to Vietnam because we're not accepting the cardboard anymore. So we burn it at the H power plant. So it's turned into energy to replace coal at the coal power plant at Kai Point. So in that regard, it's not renewable, but you're using it for multiple purposes. First, it's a shipping container, and then it's converted into energy. And it doesn't use up more energy in the process of being converted back to cardboard. So renewable resources, if you guys are looking for a critical thinking paper, you can just go nuts on looking at tracking the actual process of recycling, what the actual cost benefits and cost are in terms of energy and pollution cost of recycling of renewable resources.